Welcome to Chemi Life. If we are to look at the preparation of alkynes and I'm to break down these processes for you, now stay tuned. Let's see what we can do here. Now, the first one, hydrolysis of calcium carbide. Before we even think about the hydrolysis, there's an important thing to note. How do we even get this calcium carbide? It's very simple. Don't think too much. Okay. First of all, we use what? Lime. We attack lime with what? Coke. Now, this is what? Lime. We attack lime by what? 3 what? Molecules of coke to give us what? Our calcium carbide, which we are talking about. Now look very close. This is the formula for calcium carbide. Okay? Now that's not all. We will have a what? Byproduct. And which byproduct we will have? We'll have CO, which is what? Carbon monoxide. Okay? Now going forward, since we've gotten what we are looking for, we will have to further reacting with water. And now this water is not just any water. It's very cold water. For this reaction to work, the water has to be cold. And now that's not all. When we react what? When we react what? Calcium carbide and water. Cold water. Please let me take note of that. Cold H2O. It's already, I'm just like writing it again, okay? So now when we react this guy with cold water, what is going to happen? The reaction is very vigorous. And that's not all. The ionic bond present will break down to give us our what? Ethane that we are looking for. Now, one thing you should note about this reaction is that this preparation of alkyne is peculiar to what? Ethane, the first member of the what? Alkyne family. But that's not what we are going to have a byproduct that we don't actually need, but it's still useful. We are going to have our calcium what? Oxide. Take note of this. Alright, so now let's look at the second preparation. Sharp. Looking at alkylation of terminal alkynes, not to waste your time, let's get into the business right away. Now, we are going to use a terminal alkyne for this reaction. But first of all, we need a very strong base. An example of that strong base is what? Sodium amide. Okay? Alright, so now let's use ethane. Ethane is an example of a terminal alkyne because the what? Triple bond is in the first carbon. Okay? Alright, anywhere we can from is the first carbon. So when we react this guy with a sodium amide, what is going to happen? We are going to have am I going to say intermediate? Yes, that's the right word. We are going to have an intermediate product. We are going to what? Have a sodium acetylide. Alright? So now let's write that down. Okay? This is what we are going to get. We are going to get a what? Sodium acetylide ion. But the reaction didn't end there. It's actually going to give us a byproduct, which is going to be what? Ammonia. But we don't need that guy. We are focused on this guy here. So now, if we further react our sodium acetylide, please let me write it for you, okay? Sodium acetylide ion. Now, if the sodium acetylide ion further reacts, okay? So let me rewrite it. Now, one thing you should note about this acetylide ion is that it is very nucleophilic, okay? And now, something happens that I want you to note. There is a nucleophilic substitution that takes place between this acetylide ion and our alkyl halide. Okay, we need an alkyl halide before we are going to get our what? We are going to get our alkyne. And we are going to use this guy here, an alkyl bromide. Alright, it can actually be alkyl what? Chloride. Anyone, as far as it's an alkyl halide, that's the most important thing. So now a nucleophilic what? Substitution is going to take place and it's going to give us a what? A longer chain alkyne extended by what? 1 carbon. So now let me write for you. Alright, this is actually what we are going to get. Obviously, the reaction is not going to end there. We're actually going to get something we're actually not looking for. We're going to get probably sodium bromide. That is what we're going to get. Okay, so now let's just move quickly to what? The next preparation. Yes, sir. Now, looking at the third preparation, dehydrohalogenation of vicinal dihydride. This is actually simple. From the name, you can tell we're actually going to remove hydrogen and halogens from what? The vicinal dihalide. So now let's just go straight into that. Now we're going to use this compound. Alright, now we are going to use this compound. Now the name of this compound is what? We are going to name it 1, 2, 3, 4. We know it's what? Both, right? We know it's both. So it's going to be what? 1 and 2, 3, right? It's going to be what? 2, 3 dibromo what? Putin. But that's not why we are here. Let's just go on to the reason why we are here. So now we need a very strong base for this reaction to occur. And I just got the hook, I got the plug for it. Okay, so now when we react this guy with what? Potassium hydroxide. When we react this guy with potassium hydroxide. Now, actually it's a two-step reaction. But not to waste our time, actually, see how it works. If this guy reacts with this guy, it's going to remove what? One bromine and one hydrogen. Forming what? It's going to form an alkene and water. But now, so that I don't waste time, we are going to actually use 2 molecules of this guy so that it will just remove what? 2 of them and 2 hydrogen at the same time to give us what? Our what? Alkyne that we need. Okay? So now, see how it works. We are going to get our alkyne that we need. Now, you must be wondering, how do we know that this is the position of the triple bond? It's because actually the position of the bond is going to be where the halogens are. Now we know that we have 2 halogens in this carbon. We know after removing them, the bond that is going to form is going to form in that position. So first of all, after we remove the first one, we are going to get an alkene. That alkene, the double bond will be positioned here. Then when we remove another bromine again and another hydrogen, we will still have another bond that will be formed there. 2 pi bond and 1 sigma bond. That's a 2 pi bond and 1 sigma bond. Okay, do we understand? But that's not all. We are going to what? Have what? We are going to what? Have a product, and we are going to have something like this. Why am I to write it? Should I write it? No, let's write it here. It's part of the product, so let's write it here. We are going to have potassium what? Bromide. Actually 2 molecules and what? 2 molecules of water. Okay, this is actually what we are going to get. So now this is our alkyne. We prepared our alkyne by what? Dehydrohalogenation of vicinal dihalide. So now let's move over to the next deal of the day. Now this is quite easy. Dehalogenation of tetrahalide. Now from the name we can tell we have to remove halogens. And now the halogens we are going to remove is actually from tetrahalide. Now let me show you the diagram, the structure of tetrahalide, so that you don't get confused. See what we are talking about? Actually, we can simply write it like this. We can simply write him like this. We can simply write it like this. Okay? If we are going to use bromine, we can easily write it like this. But now, so that you don't get confused, let me draw a bigger structure for you. Okay? Alright, see what we are talking about. This is what we mean by tetrahalide. Okay, now, seeing the structure plain and clear, what do we then do? Now, something happens. We need zinc dust. I didn't say just zinc, I said zinc dust. Now, zinc dust reacts or attacks this organic compound called tetrahalide. Now, it's not just a normal zinc dust. 2 molecules of zinc dust attach this guy to actually remove the bromine atoms present in this compound, the halogens. On removing them, it will give us our what? Alkyne. And we're actually going to get a corresponding what? Alkyne. Okay? Are we good? Actually, the reaction doesn't end there. We're actually going to what? Get a byproduct like what? Zinc what? Bromide. This is actually what we are going to get. 2 molecules of zinc bromide after getting our alkyne that we actually need. Okay? So this method is very important because it's the most used method to actually prepare alkynes. Please note it. The halogenation of our tetrahalide. So now let's move forward to the final D for today. Alright guys, now the final method. This is actually the most industrial method. It's actually used in industries to produce alkynes. Okay, now we say the partial dehydrogenation of alkynes, what are we talking about? It has to do with the removal of what? Hydrogen molecule. Okay, so on that note, what do we do? As we have here alkanes, we use an alkane. So now, let's use this. I think this the simplest we can understand, the simplest example. Okay, when we use this alkane called what? This is what? This is what? Ethane, actually. This is ethane. Now, we do what? How this thing works is that on getting an alkyne from an alkene, we get it what? Via an alkene. First of all, it will have to be reduced to an alkene before an alkane. And how does that work? We use a what? Metal catalyst. And which metal catalyst can we actually use? We can use what? Chromium 3-oxide. Or we can actually use what? We can use aluminium oxide. Any of them can actually work to do the reduction. Okay, on that note, we now reduce this alkane to what? An alkene. So, but that's not all. We are forgetting something. High temperature is needed for this reaction to take place. And this high temperature is about 400 degrees Celsius to what? 600 degrees Celsius. On this high temperature and in the presence of this metal catalyst, something is going to happen. Hydrogens will be removed and double bond will be formed. We will now have, see what we are now going to get. Sorry, yes, this is actually what we are going to get. We are going to get an ethane. This is ethane, we are going to get an ethane. On further reaction, like with the same conditions and everything, we use our chromium 3-oxide or aluminium oxide in the presence of the same temperature. Guys, what are we going to get? We are actually going to get our what? Our alkyne that we are looking for. Okay, so let me write it down here. We're actually going to get our alkyne. And which alkyne is this? This alkyne is what is called ethyne. So from ethane to ethene, from ethene to what? Ethyne. Do we understand? This method is the most industrial method used in preparing ethane. Please note them. Okay, thank you for watching. Make sure you like and subscribe and share to those who are going to be in need of you. See you next time.
If you get opportunity to travel out of the country, what you miss for Nigeria?
Which I go miss? What I go miss? I go miss a lot.
Get out. Like what?
Especially food. I go miss food. I go miss
Never
food.
cry. I never go anywhere.
Especially a banner for
Let's go and chop this.